is tomorrow. Yes. Yes. Go really quick. I will. Last day I will see you will be tomorrow. That is correct because you guys won't have your even classes on Thursday. So, all right. So the review for the CBA is right here. You can use it on the test. Now, I have not actually seen the CBA, but some of the chemistry classes have been taking it, and it's pretty dang evil. We did not make it. You guys have your even ones, which is this class, tomorrow. So, I don't know what I did with my clicky thing. Where did I put it? All right, so I just pulled this thing together this morning. I didn't even open up the review to be able to do this until when I got here this morning at about 7:30-ish. There is no, y'all, there's no opener today. Ms. Castleberry's the one that did up this review, and she says it's very, very similar to the types of questions that are on the test. It's just not like the exact question. So, you have a couple of molar concentration problems that you're going to have to be able to do. Y'all, where the molar concentration of the first thing times its volume is going to be equal to the molar concentration of the ending solution times its volume. They're going to be equal to each other. Now, I do know you have to be able to convert from milliliters to liters. So that's why one of these, it's not this one, it's the next one. One of the volumes is in liters and the other is in milliliters. You have to be able to do that. With this particular problem, I'm starting with the 9.2 molar concentration of sodium hydroxide. Its volume was 3 liters. Okay, so those goes with each other. Those go with each other. That was bad grammar. And then it's diluted 2. So the second volume is, I'm sorry, not volume. The second concentration is 6.2 molar. We want to know what the volume is of this new diluted solution. So we're solving for V2. You're going to have at least one, if not 2 of these. So I have not physically laid eyes on the test, but Ms. Castleberry has, and she's the one that did the review. So they just don't let us see it. So you're going to multiply the ones times each other, and then you're going to divide it by the second situation that you know. It's just been a little while since we've done solutions, and the bulk of the stuff that's actually on your CBA is 5th, 6 weeks material, which I don't think is fair, but that's what they did. The people that make these CBAs. We don't, chemistry is the only subject that did not have the opportunity to make, from the teachers, make their own CBA. They're the only one. It's not fair, but that's what's happening. So we're going to multiply the ones, okay, and then we're going to divide it by the second situation that we do know. And the new volume of this diluted solution is going to be 4.5 liters. It's just been a while since we've done it. I think there's 16 questions on your CBA. I think. There is some nuclear chemistry on it. Yeah. There's one right here. Now, like I said, you can use the review on your test. So, because I'm not going to throw all of these equations up on the board, but this is how you're going to figure out the molar concentration, knowing 3 of the 4 bits. In this case, you're just solving for the second volume. I gave people one last chance to turn in their notes, and some people did and some people didn't. And I'm not opening it back up. They were technically due last week. I had a moment of empathy, and I opened it up for one more day until midnight. Well, 11:59 last night. And I've already gone through and I've pulled stuff out of Canvas and I've thrown it in the parent portal. No, I cannot remember anybody's grade off the top of my head. I have to go into it once we're done with this. So really the only grade that should be left is the CBA, which is being treated as a regular test grade. Now I did drop a test grade. I am not dropping your CBA. I did drop a test grade and I dropped 3 daily grades, I think it was. I'm not, don't ask me for a crossword puzzle, don't ask me for, no. The CBA? It's tomorrow. No, the notes. There was one on unit 12 on nuclear chemistry. I'll have to go back and take a look at it because my brain is so overloaded right now, I can't think straight. All right, now the second one is another one of these. Okay, but the difference with this one is you've got one volume that's in milliliters and one volume that's in liters. And since I know you have to be able to switch from milliliters to liters, we're going to move everything into liters. You would still get the same molar concentration if you put them both in milliliters, but like I said, that's not the way that they want you to change things on the CDO. So I have 1 times 10 to the second milliliters, so I'm going to move the decimal to the right 2 places. That's 100 milliliters of 11.2 molar base. Those are going to be my M1 and my V1. I'm going to dilute it to bring the new volume to 0.63 liters. And I want to know what the new molar concentration is. So this is what I do. Oh, that's supposed to be an M, not an L. There's my first typo. Like I said, I just did this morning really quickly. In fact, I finished some of it up. I finished some of this up during last period when I came back. So I know both ones. I know my second volume. So I'm going to multiply my ones and then divide it by the 2 that I do know. Oh, and then the way that you switch between milliliters and liters is once you're in milliliters, which I just took it out of scientific notation, you divide it or move the decimal 3 places to the left because there's 1,000 milliliters in 1 liter. So if you need to well, here, I'll just add that onto the slide. I'll add that up here. Probably should have put that on here and I didn't do it. Tab, go off that. So there's 1,000 milliliters in 1 liter. So I don't want you, since I know you're going to have to do this conversion factor, I don't want you to not have the information that's necessary to pass the test. Y'all, shh. If you do the math correctly, and as long as I did not push a wrong number, like on the calculator, which I very well could have done, I get 1.8 molar concentration of sodium hydroxide. All right, now we'll come back and do some more math stuff like this. But are there questions, because this was the same equation or formula for both of this problem and the previous one. Is there a question how I got this or why I had to change this one to liters? Yeah, we're still writing that down. Are you ready? Because we need to start analyzing these graphs, these charts. Allergies are horrible right now. Yes.
Go back.
Oh, go back? I'm sorry, Brady, what? I can't. Let's try that one more time and shut your trap while I'm trying to talk to him. What? Yes. Good Lord. Got it? All right, so these solubility curves. Okay, I've got different substances that are represented by different lines. And it's going to have the increase of temperature on the bottom. Okay, and you're going to have how many grams per 100 milliliters of water will dissolve into, like, whatever this is, whether it's the sodium nitrate, potassium nitrate, the ammonia. You have to be able to go at, now, the first one that you guys have, which salt has a solubility curve which resembles the behavior of the gases in a solution. Okay, so before you can even try to figure out which one's which, you have to know what happens to a gas. In order to make the gas go into solution, there's 2 major things that you can do. You can either increase the pressure on it, which this has nothing to do with, or you can decrease its temperature. That's why we refrigerate sodas, especially after they've been opened. It helps keep them from going flat. So gases, as they go warmer, they're less soluble because as a gas gets colder with the liquid, whatever it is that you're trying to put in there, it increases the solubility. So if I'm trying to figure out which of these solid salts is similar to a gas in a liquid, if you increase the temperature, you decrease the solubility. And there's only one curve that goes down as we go from left to right. Which one is it? The NH3. I know it's hard to read that because every now and then they have to like clean the copier properly because it does that to your papers. It just has extra ink that gets left behind on the rollers, and yeah, I couldn't get it to go worse or better. So, but all of the other ones, including the sodium chloride, the salt, as you increase temperature, you increase their solubility. So yeah, this whatever question is similar to this on your test, you have to be able to think extra steps to be able to answer the question. But I just haven't seen it. We've got these compounds. It says that this chart was created using a solubility rule. It's the ammonia. It's the only one that goes down from left to right. Yeah, all the other ones are increasing in solubility, which is the opposite of what a gas does. No, but you need to understand, because this says which of them is similar to a gas. You have to understand what affects a gas's solubility into a liquid. It's either increasing the pressure or it's decreasing the temperature. So if you increase the temperature of a gas, it decreases the solubility. The only one of these that does that is the ammonia. All right, this chart. Now, in order to figure out if something precipitates, there was this big chart that we could look at where it was either going to be soluble or insoluble. You don't have to worry about that big chart because apparently you just need to understand what a precipitate is. When you combine different compounds that are in a liquid state, sometimes it forms a solid precipitate. It makes the thing cloudy, or it actually like sinks all the way in the bottom. According to this, the lead nitrate and the sodium iodide do form precipitates. They are insoluble, whereas the hydrochloric acid and the sodium hydroxide do not form precipitates. They form water instead. So those are soluble. This is, I can't really tell you more without actually telling you the specific question that's on the test. You do not need to use that chart. You do not need to be able to predict if it's a precipitate or not. But you need to be able to look, like the precipitate on the top one is the lead iodide. But like I said, here, you're going to make sodium chloride and you're going to make water, but they're not going to precipitate. And the reason why the salt won't precipitate out is because it's dissolved by the water itself. Because water is polar, and it likes to work like a magnet, and it's a bully. It pulls things apart. What is Miss Humphrey sending me? I'm afraid to hit play. Something in her work. I have no idea. Maybe another rat got electrocuted in lights. Oh, that stunk so bad. All right, next one. What? Oh, okay. I try to blow my nose, even though I know it's not going to help. I've been coughing all day. It's horrible. At least my voice sort of came back.
I never figured out why you're allergic.
It's the horse apple pollen.
Not always because you're allergic to me.
No, how would I be allergic to a person?
Stop there. You're allergic to it. And you're allergic to drugs. Who else?
I'm already allergic to
She didn't deny it.
Except, don't get me wrong.
You know what? Technically, I did not write that correct. Technically, the precipitate is the lead iodide. Technically, but when these react with each other, yes, they do form one of the two products as a precipitate. The sodium nitrate's not. It is soluble. It is the lead iodide. It is the PDI that is the precipitate. The two products of these guys, they don't. They're soluble. Horrible. You would think that all of the rain that we have in the air would flush the pollen out of it. It's just not. Are you ready? Yeah? Okay. Water is known as the universal solvent. You need to know why. It's a little bit more complicated than what I put up on here, but because the fact that water is a polar molecule, it's got those hydrogen bonds. If I draw the water up here, which I know I can't see this, but if I draw the water molecule, it looks like this. You have slightly positives where the hydrogens are, and you have slightly negatives where the oxygen are. Yes, it's still neutral overall, but this arrangement where you have basically like a magnetic north and south, you have a positive and a negative, lets water to work like a magnet. And the oxygen side that has the negative electrons clustered on one end are going to go after a positive ion. Okay, and then the positive side of the water, the two hydrogens, they're going to go after the negative ion. And as long as water is stronger than the bond of the ionic compound itself, it's going to pull it apart. This is why salt dissolves in water. Whoops, I thought there was one more. I should probably get the cheat sheet. Water will pull apart things that are ionic compounds, not all of them, but the bulk of them, and it will also pull apart other things that are polar. So, like a magnet, it's called polar, it pulls like a magnet. Now, not all ionic compounds will do this, like this stuff. This calcium carbonate, or what you guys commonly call chalk, I could crush this up into the smallest chalk particles possible and throw it in water, and they still would not dissolve, even though this is ionic. I know they don't go that far into it on this video. But yeah, left and right, the other chemistry teachers that are giving the test are like, this is just awful. They didn't even get their review. The odd, no. Wait. If they have any seniors in their odd classes, they do get to do this. We sort of did it last second. Oh.
Do you know what seniors or what period seniors are testing for today?
Today or odd classes? Tomorrow, everybody's doing their evening tests. But yeah, I won't see you guys on Thursday because there's no evening classes on Thursday. You're still blowing my mind up about the CBA. I have to see what they have to do.
Not evening on Thursday.
Oh. They pulled the safety shower in her class.
The what?
This one for somebody pulled the safety shower in her class. I don't even have one of them in here. There's a shower in there. I don't know, because they're wanting to get thrown in DAP like 2 days before school's over with. If you pull that safety shower intentionally and there's not a reason for it, yeah. Well, I'm assuming that it will because it's been that way at every school I've ever taught at. Now, this another solubility curve. We're going to compare the potassium chloride, which is this one, this darker blue, and we're going to compare that with the potassium nitrate, which is this green one right here. And it's not colored on your paper, sorry. Okay, now I want to know at what temperature they have the same solubility. So where they crisscross, and so the one on the left is the mass. So that's going to be, both of them are going to be able to dissolve in 34 grams in, and then when I go down, It's between 20 and 30, and I put it at approximately 24 degrees Celsius. If it asks how many grams, that's on the left-hand side. If it asks temperature, that's on the bottom. And then it says, which seems to be affected more by temperature? They both go up, but the one that goes up steeper, which means it's more heavily affected by an increase in temperature, is the potassium nitrate. The steepest of all of them looks like the calcium chloride. And the only one that decreases on here, because like I said, I've not seen your CBA, that behaves like a gas, would be the calcium sulfate. That's the only one that goes down. The one that would be affected the least, if they asked something like that on the CBA, I don't know. The one that's affected the least would be the most flat line, which would be the salt, the sodium chloride.
Which one's the most effective?
Between those two, the one with the steepest upward slope is the potassium nitrate. Now, if it just asked in general on here, which of all of them was affected the most by temperature, then it would be the calcium chloride because it has the greatest increase over the shortest temperature range. If it asked which one was affected the least, it would be the flattest line, which in this case would be the salt, sodium chloride. They're technically all salts, but what we eat too much of is sodium chloride, salt. Which is why we call it salt. It isn't salt. I don't know, hopefully you guys having a review will help with your grade on this test that you have to take tomorrow. Oh.
No.
Oh, it's not coronavirus. Pollen. I just want to go back to bed.
Oh, no.
Okay, I already mentioned this a couple times, which means it's on the test a couple different ways. What factors make gases dissolve better into a liquid? So if you increase pressure, okay, which like I said has nothing to do with solubility curves, if you decrease temperature, you're going to be able to put more of the gas into the liquid solution. Increasing the temperature reduces solubility. Decreasing pressure reduces solubility. Now here's something that we didn't go over. It's on your test. Somehow, I don't know how. What makes something a strong electrolyte and a strong acid? Now we did talk about what makes things good electrolytes. We did talk about that. It's been a while. This is a very long sentence, so I will paraphrase this. I yanked a couple of these off the internet because I was running out of time. Strong electrolytes, they're normally ionic compounds, first and foremost, a metal and a nonmetal. In order to be considered a strong and not a weak electrolyte, most of your solid, which is what's going to be the case most of the time here, most of your solid had better dissolve. That's what this means. So you've got positives and negatives floating around, which carry electrical charge, conducts electricity, which makes them an electrolyte. If not a lot of it dissolves, then it's a weak electrolyte. Believe it or not, I actually clean that answer up a lot. Now, the one that I couldn't fit on here was what makes it a strong acid, so I put that on the next slide. So once again, this shortened down, strong electrolytes, normally ionic compounds, most of the solid dissolves to be strong. To be weak, not a lot of the solid would dissolve. Brayden,
My phone's being retarded. I'm sorry.
Can you touch on maybe Steve's?
how can an inanimate object be retarded?
I'm gonna turn Howard off, it's not even going off, push the home button, not going home, it's just like completely frozen, I don't know what to do anymore. No, look. I'm gonna push the home button right now, it's just flat out,
Wait, you see that little across the clock?
Oh, almost sounds like you have a virus on it.
Virus from what?
You can get viruses on your phone.
I know.
It's nothing but a CPU.
Oh, you see that up there?
Well, in my phone, you know, it's not good. Maybe you can't get it.
Like I said, I have to do strong and weak acids on the next slide. Okay, so I'm answering the strong acid part at the top of the next one, and then we'll go to the next math problem. Now, strong acids are going to do something similar as strong electrolytes, but electrolytes normally come from ionic compounds, and that's not an acid. Okay, so if the acid, like hydrochloric acid, or hydrofluoric acid, or hydroiodic acid, if the hydrogen pops off from the nonmetal, which I know hydrogen is a nonmetal too, but if these things completely pop off of each other, then you're going to have positive and negative ions. If it does this 100%, all of the hydrogens and all of the fluorines from hydrofluoric acid dissociate, pop off of each other. It's a strong acid. If they don't all pop off of each other, it's considered a weak acid. We did not go over that part very much. And then your test apparently also talks about Bronsted-Lowry acids and Lewis acids. We didn't talk about any of that stuff. I think that might be like the next slide. And we have another math problem. You have one that's going to ask you about calculating molarity. So I gotta give you the formula for it. So molar concentration is how many moles you have, which is when they give you grams of a substance, you divide that by the molar mass, the number of moles. So you're going to take your number of moles and you're going to divide it by the volume, which has to be in liters, not milliliters. So you're going to have to be able to convert, knowing that there's 1,000 milliliters in a liter. So when they give you milliliters, the decimal 3 to the left. Can't be in milliliters for this. Okay, I have a known mass of 6.75 grams. So I'm going to do, I don't have moles, I have grams. So I'm going to take my mass and divide it by my molar mass, which is 35.45 plus 23.99, if I'm remembering right, periodic table stuff. I'm going to take my mass divided by the molar mass. That changes it to moles. I need to convert from milliliters to liters. And then I'm going to divide my number of moles by my liters. Oh my gosh. So it's 6.75 divided by 58.44 is 0.1155 something. I just went 3 numbers after the decimal. And then I'm going to move the decimal 3 to the left to change it to liters. Then I can do moles divided by liters. And my molar concentration of, what is this stuff? My sodium chloride solution would be 0.256 molar. Technically, these capital M's should be underlined, but I didn't do that. All right, the next one that we're going to look at is a pH calculation. And I'm going to go over it the way that we talked about it because you guys were given the easy way to do pH, and I think the question on your CDA is the hard way. I don't know. In fact, I'd have to pull my old chemistry notes from when I taught pre-AP to remember how to do it because it's been so long since I've done it the hard way. All right, pH. To calculate the pH, you're going to take the negative of this at the end, the log of your hydrogen ion concentration. There's pH and there's pOH. The magic exponent, negative 14. Can't go above that. So what you would do in your calculator is you would take the log of 1 times 10 to the negative 7th. I just used the E here instead of the times 10 because that's the way I personally read it. So you would do 1 EE negative 7, okay? And then you would push the log button. And it's going to take the logarithm of that. And it's been a while since we've done this. As long as your power is a whole number, you just take the negative of it. And the negative of a negative 7 is 7. This is a neutral compound. pH that is less than 7 down to 0 is acidic. pH that is above 7 up to 14 is basic. And the further you get away from 7, the more dangerous it is. So pH stands for the potential for hydrogen ions. The lower that is, the more acidic it is. The lower the number, the more dangerous. The higher the number is off that, up to 14, the more dangerous it is. But it's a base. Acids and bases both burn you. You don't put bleach in your eyeball. I mean, unless you really want to go blind. But like I said, the closer to 7, the less dangerous it is. Your saliva, your spit, is slightly basic. It has a pH of like 8. And it's to help counteract the acid that's in your stomach, which has a pH of like 1 or 2. And it's to help protect the first part of your small intestine, the duodenum, help to prevent it from getting burned by the acid that's in your stomach. I don't know how much you learned about the human body in biology and the way that we work internally. Because I've never taught biology. I don't know what was happening when we shut down. I think it was when we were doing like DNA and RNA last year. I say we, teachers. I wasn't doing it. I know, y'all, this is horrible. I really think I need to go get some, what's the good stuff you have to go to the pharmacy for? Claritin D? The one that people make meth out of?
Yeah.
Yeah. That's why you have to get, I mean, I don't know the process of doing it, but that's why, like, the decongestant allergy medication, you can't get over the counter anymore. You have to go to the pharmacy. You have to be, I think, 18 to get it. And they actually will scan your ID, your driver's license, to make sure that you haven't bought too much. Because people were making meth out of it. So, now the other stuff that you can get over the counter doesn't have that hyphen D for the decongestant. I don't know what it is that's the chemical that's in there, but yeah, that's not. You also can't buy Sharpies because kids were sniffing Sharpies. You can't buy Whiteout unless you're 18 because kids were huffing Whiteout. Who thinks, oh, Sharpie? Like, who even thinks that? Spray paint, yeah, but people have been huffing paint for forever.
You can't buy Whiteout until you're 18.
Yeah.
What?
just kids are sniffing it to get high.
Like today, you cannot buy whiteout.
Not the liquid version. Now this type, like the tape,
Yeah, you get the.
that you can get, but not the liquid stuff in the vial. Kids won't-
I'm gonna try this. I'm gonna have to go to Walmart and find some liquid.
Oh, like.
They won't let you, like, because I remember the last time I bought whiteout, which normally I use tape now, but the last time I bought liquid, like, it beat, and I was like, I have to be 18 to buy this? And they were like, yeah, I was like, that is really sad. Like, really sad.
I'm gonna have to try this out.
All right, we did not cover this. We have Arrhenius acids, we have Bronsted-Lowry acids, we also have Lewis acids. I have no idea how this is asked on the CDE. Okay, but Arrhenius acids, if it's an acid, it's going to increase the hydrogen ion concentration. If it's a base, it's going to increase the hydroxide ion concentration. That's how they work as an acid or a base. They're either putting hydrogen ions in or they're taking them out. Bronsted-Lowry ones, which I think it's misspelled on your paper, there's no E there. That's anything that gives a proton to a different molecule, where a base would take away a proton from the other. And then a Lewis acid is going to accept electrons. A Lewis base is going to give away electron pairs. We just did, we didn't even specify that there were different species or families of acids and bases. It was just acids, the hydrogen ion concentration goes up, and bases, it goes down. That was the only thing that we did. I'm hoping we can get through all of this because we only have like 6 minutes left. But what I can't get to, I can't get to. Hopefully, the people that are making the CDAs for chemistry will listen to us and will take out the questions that are not what's taught in class. I don't know. It would be nice if they would let us choose like a selection of questions and then let them choose from said selection of questions. But that's not, it only makes sense. It's just not the way it's being done. It's very frustrating. And like I said, what species means here is just the substance, like hydrochloric acid, just the substance, whatever's reacting. Doesn't mean like an animal. It just means a reactant. You're a dinosaur?
Yes.
I like teaching about dinosaurs this year.
This one for us, actually, I will find it for us.
You sexually identify as a velociraptor. Okay. You know velociraptors are only about this big, right?
I know.
They were about turkey sized, not the dinosaur that they based the velociraptor off on Jurassic Park was the Deinonychus. It was not a velociraptor. We had a lot of fun. I liked doing evolution.
You don't like the stegosaurs.
Okay, are y'all done with this big one?
Oh.
No?
Yes.
Got it? All right, you should know the difference between kinetic and potential energy. If it's moving, it's kinetic. Okay, so these are the different, could be rolling, could be sliding. but it is moving. Whereas potential energy is not moving. It's stored. So the object is at rest. It would be the energy that is stored within the bonds of things that you eat. You pull back a rubber band before you let it go, before it shoots across the now when shooting across the room, that's kinetic, but when it's stored, you haven't released it. That is potential. I would expect that you would be able to do this one, but just to be on the safe side, kinetic is while it is moving, and potential is when it is not moving. Then you cannot create or destroy, they will flip-flop back and forth. I know we'll at least be able to put up a specific heat problem, which means you're gonna have to be able to do the fission fusion stuff by yourself. There's just no way. I will when I put this up, I really hope I unmuted my mic. Put this up into Canvas, I'll have the last two that are on it. Okay, the last one I'm gonna put up here, the specific heat problem. Kinetic is moving and potential is not moving. But I'll put this up in Canvas if you need to go all the way to the end of the YouTube link. You may have to pause it to be able to get all the stuff down. Got it? Yeah, I do know you need to be able to solve for C. Okay, so you definitely want to jot down to solve for specific heat. It is heat divided by the mass times the change in temperature. Because I know for a fact you have to be able to rearrange for specific heat. But like I said, I will sort of go through this and then I'll stop the recording. And if you really want to, once it's uploaded in Canvas, you can go to the very end of the YouTube link. And if you don't remember fission and fusion, you should know this is fission. So you have a breakdown into smaller, more stable isotopes, the daughters. And you also need to know the differences and the similarities between fission and fusion. Fission and fusion, they both create energy from nuclei. The difference is fission takes one big one and breaks it into smaller daughters, and fusion takes two smaller parents and puts them into a larger daughter. That's the difference between the two.